Astronomers have discovered that our latest interstellar visitor, 3I Atlas, isn't the pristine time capsule many had hoped for. Data from the James Webb Space Telescope and NASA's SPHERE-X mission reveal that its surface has been chemically altered by galactic cosmic rays, radiation that's reshaped it over billions of years in deep space. Instead of untouched material from another star system, what we're seeing is the product of long-term exposure to the galaxy itself. In this video, we'll examine how scientists reach that conclusion, why it matters, and what it means for studying interstellar objects in the future. Let's get started. 3I Atlas was discovered on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Hawaii. Its hyperbolic path through the solar system showed it wasn't bound to the sun, clear evidence that it came from interstellar space. That made it the third confirmed interstellar object, following Oumuamua in 2017 and 2Hazd I/Borisov in 2019. Once identified, telescopes across the world began tracking it. Observations revealed a coma of dust and gas, confirming that it was a comet, not an inert rock. Unlike Oumuamua, whose strange motion fueled speculation about its nature, 3I Atlas behaved as expected, outgassing and developing tails under sunlight. But spectroscopy soon uncovered something that didn't fit normal cometary chemistry. Instruments aboard the James Webb Space Telescope and SPHERE-X measured an extraordinarily high carbon dioxide to water ratio, about 7.6 plus or minus 0.3, the highest ever recorded. In solar system comets, that ratio rarely exceeds 2. Even more puzzling, these readings came when the comet was still far from the sun, too cold for radiation to alter its composition. At first, scientists proposed that 3I Atlas might have formed in a CO2-rich region of its home system, or that internal reactions in its protoplanetary disk converted carbon monoxide into carbon dioxide. Yet these ideas failed to explain the scale of enrichment. The evidence pointed to a much longer external process, one that could persist long after a comet left its birthplace. That process was galactic cosmic ray exposure, the slow, relentless modification of surface chemistry by high-energy particles traveling through interstellar space. A research team from Belgium and the United States analyzed the spectral data and concluded that galactic cosmic rays, GCRs, best explain 3I Atlas's unusual composition. Cosmic rays are charged particles, mostly protons and heavier atomic nuclei, accelerated by events such as supernova explosions and black hole jets. Over immense timescales, they bombard every exposed surface in the galaxy. When they strike icy material containing carbon monoxide, CO, they break chemical bonds and drive reactions that convert CO into CO2 while producing organic residues. Experiments on Earth have replicated these reactions, and their outcomes match the spectral fingerprints observed in 3I Atlas. According to the model, this process gradually built up a radiation-processed crust roughly 15 to 20 meters thick. The material we see venting from its surface today, its coma, is drawn entirely from that altered layer, not from the original interior ice beneath. This discovery revises how astronomers interpret interstellar comets. They're no longer pristine samples from other star systems, but bodies chemically evolved by cosmic radiation during their long interstellar journeys. The surface we observe is effectively the comet's travel log, recording millions or billions of years of exposure to the galactic environment. Supporting evidence comes from the comet's reddish coloration, consistent with tholins, complex organic compounds created when radiation modifies ices rich in methane and carbon monoxide. Similar coloring is found on distant solar system objects such as Sedna and Makemake, which have also spent eons under cosmic ray bombardment. Together, these clues reveal that 3I Atlas is not a snapshot of its origin, but a product of its voyage. Instead of studying an untouched piece of an alien world, astronomers are now examining how interstellar space itself transforms matter. It's a humbling reminder that every traveler crossing the galaxy carries the chemical scars of its journey. This finding complicates one of astronomy's big hopes, that interstellar comets could show us pristine material from other planetary systems. If cosmic rays can significantly alter these bodies, then each one we detect may already be chemically aged before entering our solar system. That realization shifts the scientific focus. Rather than searching for unaltered samples, researchers can treat these objects as records of galactic conditions. The radiation-induced chemistry on their surfaces reveals information about how long they've been traveling, how intense the cosmic ray flux has been, and how organic molecules evolve in deep space. In other words, 3I Atlas has become a natural experiment in interstellar physics. As it approaches perihelion, its closest point to the Sun, astronomers will continue observing it with JWST and ground-based telescopes. If the heat penetrates deeper layers, we might briefly see emissions from less processed material, but most models suggest the Sun's energy won't reach far enough. Regardless, these ongoing observations will refine models of cosmic ray chemistry, helping predict how different energies and exposure durations affect various ices. Such research is crucial for understanding not just comets, but also the evolution of organics on icy moons, Kuiper belt bodies, and exoplanetary debris. The discovery also guides how we'll study future interstellar visitors. The Vera Rubin Observatory, scheduled to begin full operation soon, will identify these objects earlier, giving scientists more time to analyze them. Meanwhile, ESA's Comet Interceptor mission is designed to rendezvous with a pristine or interstellar comet, ideally before cosmic rays or solar heating erase key information. In short, 3I Atlas transforms our expectations. It shows that interstellar space is not a passive void, but an active chemical environment that shapes everything within it. The radiation that once seemed a nuisance now becomes a new lens, one that tells us how matter evolves as it drifts through the galaxy. Even if these travelers no longer preserve the chemistry of their birthplaces, they reveal something broader: how the Milky Way itself recycles and reshapes material over cosmic time. The Comet 3I Atlas isn't a pristine relic, it's a survivor reshaped by cosmic radiation. Its chemistry tells the story of both its origin and its long journey through the galaxy. Each future interstellar visitor will carry a similar message. The universe changes everything it touches,